Hi, my name's Hugh Vidos. Thank you for the intro. I am from Grab. I live in Seattle and I work in the Seattle office for Grab. And I want to talk about mobile app optimization. So, okay. Thanks. So really the problem I want to address is, what do your users think about your application? Do they complain that it's too slow? And that's really the problem. And so you know that you have this problem. How do you go about fixing it? So there's a lot of techniques for this. I'm going to focus on a few of them. Perhaps you've tried profiling your app, you've gone through instruments, and you've fixed all the hotspots, and it seemed you don't see any issues, but your app is still slow. So what could be causing that? And another kind of similar case to this is, what happens if your network is slow? Your app runs fine here in Singapore, it's a fast network, and then you go to Indonesia or Malaysia, and these are real problems we face at Grab, and I'm sure a lot of people here have similar issues. So how do you optimize so that you can have a good experience even when you have a slow network? So just in general, a little bit about myself. I thought I'd start with kind of an embarrassing story about myself, or an embarrassing fact. I used to work on Windows Phone. So that's actually just the setup part. There's a lot of good things about Windows Phone, and one of the really great parts about that was I got to work with the developers who are working on the operating system. So I learned a lot of secrets about phone development that I don't think are shared widely, and they really should be. The embarrassing part was I was in the Xbox Live division. We were writing games for the Windows Phone launch, and I'm sure everyone saw that parade with the coffin of the iPhone walking around. My division made us walk in that parade. That was pretty bad. So let's start off with what Grab is. Hopefully everyone here knows what Grab is. It's a ride-hailing application, and probably the really important things, I don't really like reading slides. I'll just point out.
Do you want to use the mic?
Sure, sorry. Probably the really important things to point out here is that we're not just cars and taxis. We also have bikes, we have express and food. We're in 6 different countries, 31 different cities. And then the next thing is R&D centers. Grab is not just a ride-hailing company. We're really a technology-focused company. So we have 3 R&D centers. We have the primary center here in Singapore. We have another R&D center in Beijing. And like I mentioned earlier, I'm from Seattle. We have a R&D center there in Seattle as well. So now let's get to the heart of what this is about. How do you optimize your app? There are a couple of things that are really going to make for a better experience. There is how big is your application? How much data are you using? How much battery are you using for when your app is running? And how the user is perceiving what's going on here. So why do these things matter? The application size, you don't want people to think you're using up too much space on their phones, so how do you shrink that size? Data usage, if people are having to pay for every byte that they're downloading, you don't want to abuse that trust. The same thing with battery, you don't want to use too much battery. So let's start off with file size. How can we optimize file size? First, I'm just going to briefly touch on this because Apple has spent a lot of time talking about this, but there's a great technology called app thinning. And I'll just point out what it is really quickly, point out how you can turn it on, and then point you to a WWDC video about this. But in general, what this is, it's something that will say you have to build a universal application so that it works on all the different iOS devices out there, but only download the parts that are going to run on that user's device. So the first part of this is app slicing. If you are supporting some older phones, they're 32-bit phones and 64-bit phone, the newer 64-bit phones, app slicing, which is on by default now in the App Store, is only going to download the portion, the 32 or 64-bit portion that applies to the user's device. This is only in iOS or later devices, so if you're still having to support iOS 7, sorry, it won't help you out. You should see, anecdotally, Apple is saying you should see about a 65% reduction in download size by using this. So this is a great feature that Apple's turned on. One other part of this is you can also reduce the images that are sent down if you're using Asset Catalog. So if you're using an Asset Catalog with 1x, 2x, 3x images, you're not going to download the images for an iPad Pro on an iPhone 7 if you've used a catalog. If you haven't, they're all coming down. Next is on-demand resources. This is the really great use case for this is games. So you might imagine having some sort of game, having a bunch of different image assets you need to play that entire game, but only some of them are needed right when you launch the app. So you come up with these different these different resource groups, and you have the ones that you need at first when your application is started up, and then the rest of them can be downloaded as your application requests them. How do you turn them on? So if you go into the Project Explorer, select your target, and go into the build settings and search for assets, you're going to see this enable on-demand resources. That's it. That's all you have to do. That's now turned on. Well, almost. The next thing you have to do is actually go in and use this tab that I'm sure hardly anyone has used, which is the resource tags tag right there. And that's where you set what these different groups of assets are. So then you can, there's basically three groupings. There's the initial ones, which are sent down as your app is installed. There's the prefetch, so after you've installed the app and you launch the app, then these are going to be downloaded. And then there's the groups, and you just request from the App Store, hey, I want this group of assets, and it'll start downloading for you. For your application. These are managed by iOS, so as they're no longer needed, they can be purged out of memory. So it's a good way of having assets available to your application and not necessarily having them always on your phone. I've got a link to the WWC video at the very end. So how about download size? These are just the generic technologies that Apple has, but there's other things you can do as well. So how do you make your app smaller? One thing is, if you have an audio file, do you send down a WAV file or do you send down an MP3 or AAC file? The latter two are going to be significantly smaller. For images, there was mentioned earlier of using vectors. Vectors are great. If you can't use vectors for some reason, well, don't use a bitmap. Use PNGs or JPEGs. What about unnecessary files? Do you have any test resources? Do you have anything else in the application bundle that really shouldn't be there? So take a look through all the files that you're actually including in your bundle and make sure you pull out the ones you don't need. And finally, think about unnecessary code. If you can get rid of the code, you decrease the attack area, which is a security win. You're decreasing the application size. You're making it more testable. There's just a lot of wins for reducing code. So one thought about this, how many third-party libraries are you pulling in? There is a great reason to pull in third-party libraries. Someone else has built something. Someone else is maintaining this for you. It's a win most of the time. So how do you weigh that? Well, first off, I'd like to make a plug for CocoaPods. This is a great way of pulling in and maintaining these resources. There's also some other tools like Carthage, which are great. But consider the amount of time that you're saving by including this third-party library. That's not the only time you're ever going to spend with this third-party library. You're also going to have to think about, is it going to be maintained? If it stops being maintained and you have to pull it out, that's going to cause problems. Some anecdotal evidence. I was at a place where we had pulled in a third-party library like this. We shipped the application. It turns out there's a crash in this third-party library, and we had to scramble to release a new version of our application. And this was time we didn't have to spend, or we shouldn't have had to have spent. Another one, so there's some libraries that make it easier to do things like UI alert view. So there's a framework, UI alert view plus blocks. We're using that, and all of a sudden became deprecated in iOS 8, and then it stopped working by iOS 10, and we had to spend the engineering effort to yank that out. So all the time saved up front a couple years ago was now lost because we had to re-implement this thing entirely. And just a quick tip, and I just realized this is probably the only code you're going to see in this entire presentation here. If you have test resources, and they're in your main app bundle so you can use them during your XC tests, these two things are actually going to be different bundles. So if you use the main bundle, that's going to be your application bundle. If you do bundle for class and you're running that in your tests, then it's going to grab the test resources out of your test bundle. So look for things like that too. That might be a good way to save some resources. This is probably the big one. How do you save battery life? The three biggest hits you're going to pay on a mobile device for battery, number one is screen. There's really not much you can do about that. The user probably needs to have the screen on to view your application. Number two is network, and number three is CPU and GPU. Number three, Apple, again, has a great talk on how to use instruments to look at what your application is doing, so I'm not really going to talk about that. What I really want to talk about is network. What does using the network affect on your phone? So I found this slide, or this image, and it's kind of funny. It's actually on a sticker inside of Google, and the internets are just running through that pipe there. What happens with network calls? What are we doing when we're using the network? And how do we actually make it better? So the things to think about here is right there. Network calls, latency, and what that affects battery. And I'm going to take this screen right here as an example. And I hope everyone here is familiar with this screen. This is kind of the home screen for Grab. And so it's got some information on there, but what's actually happening? What are we having to do? That's the list. We're getting the user location, we're getting the user account, we're showing the map, we're loading all these types of cars down here at the bottom, we're finding out which cars are nearby, we're trying to figure out where the user might be going. So we're making a lot of network calls to get all that stuff to populate that screen. Let's start with GPS. With GPS, there are different power levels for how accurate you want to be. And just use the lowest possible level of accuracy that you can. So beacons and geofences use almost no power. If you're using the navigation directions, it's using the maximum amount of power for GPS. So don't use best for navigation if you're okay with you just want to know what city someone's in. Also, you can, when you create your CL location manager, you can turn GPS on, you can turn it off, you can pause it. So if you just need to know where someone is, don't leave it on. Just get the location and then shut it down, and you'll have better battery life. With network calls, probably the best way to save battery or to reduce data traffic and battery life is to not make them at all. So can you cache any of the calls you've gotten previously, or can you preload the data in your application so you don't need to make that call at all? Another thing to try is there's a tool called the Network Link Conditioner app, and if you're using the simulator, you can run it on your Mac. If you're using a developer phone, you can go into Settings, Developer Tools, and turn on Network Link Conditioner. Set it for 3G and just see how your app runs. Think about how other users in other places with slow networks are going to see your app. Okay, you've done that and you're still having bad network performance. This is probably the time for you to be social. Go make friends with a server developer. Take them out to lunch, buy them a coffee, be friends with them, and then hit them up with your request. Hey, I need you to change these responses. I need you to make them look like something else. The quick thing you can do is make sure your responses are gzipped. So if you run a network proxy debugger like Charles, you can see right there in the header if it's saying it's gzipped. If it's not, turn it on. That will tremendously reduce the amount of data coming across the phone. How often are you making calls? If you can reduce them, that's great. And there's a really good reason for reducing call frequency, and I'll come back to that in a little bit. The other thing, what I like to think about with server responses is I want everything I need and I don't want anything else. The data for a mobile application should really mirror what you're doing in that screen. If you've reused an API that was used for the website and it's sending all this extra data that you don't need, that's costing you data bandwidth and it's costing you battery. So you need to talk to the server team to get the response finely tuned to what you're doing. Now, what does a response look like? And this is really important because if you think about how the data is coming down and how long it's going to take, depending on the network speed, there's not a lot you can do. So let's come up with some terms here. When you create an NSURL request, when you create an NSURL session task, and you say task resume, you're creating the request and you're starting that request being sent to the server. This response could be batched. You're going to get a call back and it might have some of the data or it may have all of the data. But it's from the time when you send your request until you get any sort of data at all from the server, that's the latency. And then if it's not coming in one request, like a really big request may not, there's the rest of the time, which is how long does it take to get all the data. So I have a couple of examples here. One, I went to Bing and looked at how long it took. And this test I ran in the US. It's on a fast network. And I just grabbed the HTML. No CSS, no JavaScript, nothing. Just a single HTML file. I just wanted to look at how long that took. For Bing, the response time was 63 milliseconds. And then after that, another 90 milliseconds to get 33 kilobytes of data. I also did a similar test for a big media company, and I'm not trying to embarrass anyone, so I'm not going to say who that was. It took almost 890 milliseconds for the response time, and then 78 milliseconds to get the data. So it's about the same data payload in both of those cases. It's about the same amount of time for the data in both of those cases, but one of them, the latency made a huge difference. So how does this help you? Think about if you have to make 2 requests to that server. In the first case, if I make I've got the latency and the data transmission, the latency of the data transmission, that's 306 milliseconds. If I could just double the size of the response, I've saved quite a bit of time. But you really save a lot of time here where the latency is really, really long. And I think you're going to find in a lot of the networks here in Southeast Asia, you've got a big latency. So sending extra data in the server response, it might make it a little bit slower for that first response, but it's actually going to make it a lot quicker for all the data to get to your phone. So make sure you're looking at how long it's taking and where you're spending time. And you can use things, again, like Charles, or you can actually just open up a web browser like Chrome or Safari, go into the debug tools, and look how long it's taking to load one of those requests. It won't be the same network, but it's a good approximation. When I mentioned earlier that I worked with some of the OS developers at Microsoft, this is the thing that I heard that I don't really hear talked about ever, and this is the thing that I think is super important and everyone needs to know about this. The antennas on every single mobile phone, oh, I forgot to ask, are there any Android developers here? Anyone? Okay, this is super secret, so you guys are gonna have to leave. I'm just kidding. This technique and the previous technique, actually, even if you've got a BlackBerry phone that you're programming for, these will work for all of these things. This isn't iOS specific. A couple of these things are, but this isn't. Every mobile phone has an antenna, and it's got 4 power transmission states. There is the airplane mode, which is using 0 power, And then at the highest level, we've got the high power transmit and receive. So when your phone is actively transmitting or receiving, it's in this higher powered state. It takes virtually no time from when you tell the phone you want to send data or receive data for it to do that. It uses a lot of power though. So there's this intermediate power level, the medium power transmit receive mode, where after you've been in high power transmit and you haven't sent or received data for some period of time, and this is based on the hardware implementation, it could be up to 30 seconds, it drops down to this medium transmission state, and it still uses quite a bit of power, but not as much as the high power mode, but it can shift really quickly back into that high power state. The antenna is on, and it's ready to transmit, but it can't transmit just yet. And if you don't do anything then it's gonna drop down into the active standby mode. And this is the mode that probably everyone, well, maybe half of the people here that aren't on Facebook or something right now, it's what your phone is in right now. So why does this matter? So let's think about this red is the high power, this is the medium power, and this is the active standby. If I make a network request, like this bar right here, this black bar, I put the phone into the high power mode, and then I don't do anything for a while, and then it drops down to medium power mode, and then I send out another request, it puts it into high power mode, drops down to medium power mode. You can see what's happening here. So if you think about the height of the bar, that's how much power it's using, and it's a long time before it drops down here. If instead I make 3 requests pretty quickly, I'm going to stay in the high power mode a little bit longer for this first one, drop down to medium power mode, and then I stay in the active standby for a longer period of time. This pattern here at the bottom is going to use a lot less power. So wherever possible, try and batch your requests. Don't go to unreasonable conniptions to change your application to do this, but if you can think about, well, I'm going to get this data, I should get this data as well, you could end up having a significant battery impact. Now, let's talk about user experience. Oh, does anyone like these? Yeah, I don't either. Let's get rid of that. You have to have these UI activity indicators because a lot of times your program is doing something and you don't want people to think that your application's hung. So you've got to be doing something so the user knows, okay, it's just busy, I'll wait. But no one really likes it. How do you instead change the user's perception? So I like to think about are there ways of kind of hiding that wait that don't involve the spinner there? One good example would be as your application's starting up, probably everyone has a splash screen. That's a great way. You get a bunch of data at app startup and you show the splash screen and people don't really notice how slow your application is at startup. You do something to entertain them then. Some other things I've seen is if you have an application with 2 pages and you click a button and you immediately transition to the next page, the user probably expects that the data is ready because you just transition to the new page. If you show a wait cursor then, as soon as you load the new page, it's annoying. If instead the user clicks the button and you show the wait cursor there, I'm sorry, UI activity indicator. I used to work on Windows. Sorry, I'm letting these old terms slip in. If you show the activity indicator as soon as the user clicks the button, but you don't transition to the new page, now this indicator is the user kind of expects it because I just clicked on the button, the app has to do something. So thinking about when to display these things is important, but it's better if you don't display them at all. So there's another example I can give you. I used to work on a program called Windows Media Center. And, oh, it's not that bad, come on. So one of the things you could do in there is there was a database of all the TV shows that were coming on in the next 2 weeks. Well, at least in the US there was. There were hundreds of thousands of shows. And so if you went to load something, like I want to search for all the episodes of SpongeBob SquarePants or something like that, because I'm really into SpongeBob. We were able to make that request and show all the episodes, and it took us about 6 seconds. And this was about 15 years ago, so the computers that we were running, the fast computers, were significantly slower than this thing right here. So 6 seconds was pretty good back then. And we were really happy with the results, and then we put this into user testing. And we got some people that weren't on the team to try this out, see what they thought about it. And then we also showed them some competitor products to see what they thought. And we were pretty happy because we were at about 6 seconds, TiVo was about 15 seconds, but almost every single user liked TiVo better than us because it took them 15 seconds to get all the data, but after less than a second, they were showing a couple of the results, and then they would trickle in. So to the user, TiVo's search finished in about a second, and ours took 6 times longer. So think about how the user is going to perceive what you're doing. If you can show something sooner and then have results trickle in, you can do that instead of showing an activity indicator. Ooh, I'm almost out of time, so let's see. Why don't, just to summarize. Kind of talked about how you can reduce your application size, how you can think about data usage and battery life, and how you can change the user's perception of what your application is doing. And finally, let's see, here are some references. Actually, let me just come back to this slide. I'm going to open it up to questions, but I'll put it back on the slide there. There's my contact information. I really want to thank everyone. This has been a great conference, and thanks for inviting me here. Thanks. Sorry about the mic. Yeah.
Any questions? Of course.
Hi, Hugh. Like to talk really, really thought-provoking. I'm wondering, do you have any sort of statistics you're able to share about like the different network connections, device usage and stuff like that between the different regions your app is available in, and how that sort of affects decisions you make?
The great thing about statistics is about 90% of them are made up. So, do I have statistics about what the different network conditions are in the different Southeast Asia regions?
Yeah.
Not really. I can tell you anecdotally, it's awesome in Singapore and not so great in the rest of Southeast Asia. It's like 2G, 3G speeds. And this we're seeing through more or less user feedback rather than pure analytics. And we're working on addressing that.
Yeah. Have you ever, you've said you're addressing it, are you addressing it through gathering analytics and data and stuff like that as people use the app, or are you looking at other approaches?
I like the magical other approach. Do you want to elaborate on what you mean by other approaches, like going to telcos and asking them, or really what we're doing is analytics in the application to find out things like how much data we're sending, what kind of connections users have, if there are interruptions in connections, that sort of thing.
Yeah, that's that sort of thing that I was interested in.
Okay. Yes, so no, we're doing that. There's not really any other method that I'm aware of that's reliable in all these regions.
Are you doing it via just your own built stuff, or using something like New Relic, or?
A mixture of both. So we
hello, sorry, Hugh.
Yes.
To answer your question, we do have some kind of instrument. So we are tracking where the user are on which kind of networking. But at this stage, Hugh is correct. We are just knowing which network they are. We are still trying to optimize the experience according to different type of networks.
Cool. Thanks.
Any more questions? Oh, there's one here.
Thank you. Hi. Really nice presentation, but there's one conflicting thought in my mind. So initially you say that it's better that we split up the network and show only what is required. And then you go to the battery consumption screen and then you say, why don't you hit everything as fast as you can so that you save a lot of battery. And then you go to a screen where you say that if we get all the responses together, then the latency gets decreased, because if you get it on demand, it's going to be a huge latency in there. And then you have an example which says that on demand is better. So I'm having difficulty to understand where exactly is the trade-off. When should we do everything together and when we should not? So, yeah.
The problem with what I'm talking about is there's no absolute answer that works for everyone. And so what I tried to do is talk about the different factors that are going to affect different cases. In a lot of cases, bundling as much data up as possible into a single request is going to be good. And in some cases, I don't know that when I mentioned, or I think when you said split up the request, you were talking about the case where I showed 3 things. That's not really about splitting up the request. That's just saying if I'm hitting server endpoint A, server endpoint B, server endpoint C, for instance, it's better to try and do those as close together as possible. I don't really know of any case where taking a single response and splitting it up into multiple, unless you're concerned about the amount of total data being returned by that response. I don't know of any case where splitting it is a good thing. But in most cases, it's really about understanding what is going to affect your performance and battery life and making the best decisions for your application. So unfortunately, I can't really say this is the guideline in every single case because there isn't really that answer.
We'll take one more. Okay.
Have you experimented with any binary protocols like protobuf? And if so, have you seen any huge performance gains or anything like that?
Yes, I used to work at Google and they use protobus for everything. It is, I think, about a 6% reduction in data traffic for protobufs. The nasty part about protobufs is you have to import another library. And it makes it more difficult to inspect the data as it's going over the wire. You pull in another library, it's an extra step in getting the data out. But if you really need to reduce the data, then it might be the right way to go for you. I would suggest looking at your overall data budget to begin with and find out if there's other places where you can reduce traffic first, and do all of those exercises first. And once you've done that and you still haven't received the benefits that you're looking for, then look to a binary compression protocol. If you're using gzipping in your service responses, you're already going to be sending back binary data. It'll be a little bit bigger than protobufs, but you're already sending that back.
Thank you. Thank you.
Thanks.